Let's try one more practice with average rates, the rate expression that uses stoichiometry. It says the decomposition of dinitrogen pentoxide, produces nitrogen dioxide and oxygen gas. Let me reread that, see if we have our skeleton correct. The decomposition of dinitrogen pentoxide produces nitrogen dioxide and oxygen gas. We have our skeleton. Let's work to balance the equation. Well, I could start here by doubling the n's, but then I still end up with an odd number of o's. So I think, let's try this. I'm going to double this, get 4 n's, and see if this even number of o's can work over here. We have 10 o's on the left, 8, 9, 10 on the right. So a 2, 4, 1 balanced our equation. If the rate of decomposition of the reactant at a particular instant in a reaction vessel is 4.2 times 10 to the negative 7th molar per second, what is the rate of appearance of our two products? Well, let's get our stoichiometry set. Negative 1/2 times the change in concentration of our reactant over time is equal to, and let's just target that first product, it would be 1/4 times the change in concentration of NO2 over the change in time. They're letting us know that the reactant rate is decomposing with a rate of 4.2 times 10 to the negative 7th molar per second. Let's pull out this expression, the change in concentration of NO2 over the change in time. If we'd like this side by itself, we'll need to multiply both sides by 4. And friends, disregard the negative sign. It's there by convention to let you know reactants are disappearing. We will never, ever, ever have a negative rate. It'd be like driving backwards down the highway going negative 55 miles per hour. It makes no sense. Rates are always positive. So what we'll end up hitting is 4/2, 4 times 1/2, times the rate that was given of 4.2 e negative 7. And I find 8.4 times 10 to the negative 7th molarity per second. That was our first product. We were actually asked to solve for both products. Well, that same ratio, and again, I'm putting negative to remind us that it's disappearing, but rates are always positive. The rate at which our reactant is disappearing, 4.2 times 10 to the negative 7th molarity per second, is equal to, and notice the coefficient here is a 1. So it's equal directly to the change in concentration of the oxygen over the change in time. And that's what we were asked to solve for. So this one is as easy as hitting 1/2 the original rate. So 4.2 e negative 7 cut in half gives us a value of 2.1 times 10 to the negative 7th molarity per second as the change in concentration of oxygen over the change in time. That represents the rate at which oxygen is being made. Reactants are consumed. That negative sign is there by convention. It is not showing that we have a negative rate. Let's pause there and take a look at an assignment. We have enough ammunition to look at lesson 1.